Hello, in this new lesson, can we learn how to solve quadratic equations using the factorization method? So, we can start by factorizing the common factor, which sometimes we call it the highest common factor, or HCF. So let's say, for example, you have a question like 6x squared plus 9x is equals to 0. Let me copy it in my board. The first step here is to find the HCF, or the highest common factor, for the numerals. And as you can see here, we have 6 and 9. Those are the numerals. Then we have x squared and x. Those are the variables. So we can start by finding the HCF of the numerals. And this is how we go about it. 6 and 9, I can just write it like that. And then I can start these two, 6 and 9 can be divided by 3. So I divide by 3, here I get 2, and here I get 3, like that. Then from there, I also ask myself, is there another number that I can divide 2 and 3 without a remainder? There is none. So after there, I can say the highest common factor of 6 and 9 is 3. So HCF of the numerals is 3. Then the next step is to find the HCF of the variables, where we have x squared and then x, like that. Then I repeat the same process, and in this case, you see we have x here and we have x squared here. I can divide both by x, like this, because if I take x squared divided by x, it will be by x1 by x. Here it remains 1x, because x squared is just like x multiplied by x. So when I divide by this x, then we cancel 1x and we remain with 1. So it becomes x, and then this x divided by our x here, it becomes by x1 by x1. So it becomes 1. And now that we have x and 1, then the next value which can divide these two without a remainder is just 1. And if I put 1 there and divide this x by 1, it will still be x, and this 1 will still be 1. So nothing will ever change. So I only need to take this x as the HCF for our variables. Now, to get the combined HCF of both of them, I need to take the HCF of the variables multiplied by the HCF of the numerals. So I need to take 3 multiplied by x, which now becomes 3x, like that. And now that I have the combined HCF, of course HCF is the highest common factor. So from there, I can start with it here and say 3x into, I come back to my equation here and I check what can I divide 6x squared with, so that once I multiply that value with 3x, I'll again get this 6x squared. So I can just do it like this. Take 6x squared, then divide by 3x. Very simple. So this x goes with that, then this x here, because there were 2, it remains 1, because I cancel this x by 1, this, then remain with this x here, then by 3, 1, by 3, 2. So it becomes 2x here, because I remained with 2x here. So if you take 3x multiplied by 2x, 3 by 2 is 6, then x multiplied by x is x squared. So it goes back to 6x squared, then plus, I repeat the same with 9x here, 9x divided by 3x. This is our common HCF. So this x goes with this 1 by 3, 1 by 3, 3. So I put 3 here, so that 3x multiplied by 3, 29x, then it will be equal to 20, like that. Then from there, everything outside the brackets, 3x will be equal to 0, this 1. And again, 2x plus 3 will also be equal to 0, like that. So, to get the value of the x here, I'll just divide both sides by 3. And if you take x divided by 3 divided by 3, there it will be x is equals to 0 divided by 3 is just 0. So the first x is 0. Then the second one, here we have 2x, and then we have this 3. I can take it on the other side, so it becomes 2x is equals to negative 3, like that. But I want x, so x will be equal to negative 3 divided by 2. And I can just leave it like that, and that becomes the second solution for x. And that becomes the solution for this question. Can we try another example? 4x squared minus 12 is equals to 0. As usual, we need first to find the HCF of the numerals, and in our case, the numerals here are 4 and 12. So, I take 4 and also 12 like this, then put like this, then 4 and 2, 12 are divisible by 2, so I can divide by 2, and I get 2 here, because 4 divided by 2 is 2, then 12 divided by 2 is 6, and again I can also divide again by 2, so I get 1 here, then 6 divided by 2 is 3, like that. There is no another number that can divide 1 and 3, and we don't have a remainder, so the HCF for the numerals becomes, HCF for the numerals becomes 2 multiplied by this 2, which is 2 by 2, which is 4. So we repeat the same with the this variable here, but you see in this case we only have x squared as the variable, and sorry, we also have an x here, I'd forgotten. So we find the x squared and x HCF. So of course it will be x squared, then x, then I put it like this, then I start dividing by x squared divided by x, it will remain to be x as we did in the previous example, and this x divided by x, it will be 1, just as we did in that previous example, and there is no another value that can divide these two, and we don't have a remainder, so the HCF for the variables becomes x. So to get the combined HCF, now it is 4 for the numerals multiplied by x for the variables, so it becomes 4x. And now that we have the combined HCF, then I can factor it here. So it becomes, I can put 4x outside, then I come back here and ask myself, what will I multiply with 4x to get 4x squared? If you don't understand that, it becomes very simple, because you can just take this 4x squared and just divide by this 4x here. Like this, and this x goes, here we remain with 1x, and then this 4 goes, and this 4 goes, so we remain with x, and when you take x multiplied by 4x, it is 4x squared, then minus this 12x, you can do the same, let me do it here, 12x divided by 4x, this one goes with this one, then by 4, 1 by 4, 3, so it remains to be 3, is equals to 0, like that. So in this case, then it means 4x is equals to 0. Then we divide both sides by 4, so we get x is equals to 0. Then the second one is x minus 3 is equals to 0, this one. So x is equals to, I take 3 on the other side, so it becomes x equals to 3. And becomes the two solutions for this question. Can we try to factorize some advanced problems? Like in this case, we can try to solve a monic quadratic, and simple monic quadratic just means there is no coefficient in the x squared, the coefficient is just 1. So in this case, if I take x squared, you can see here we have nothing, so it means it's just multiplied by 1. Same case with this one, but a non-monic quadratic means the coefficient of x squared is not 1. So for example, in this case, we have 2, which is the coefficient is not 1. Here we have 3 is not 1. So that is the difference between a monic and a non-monic quadratic. Let us try to solve this one using factorization. The equation is in this form of a quadratic where a is the coefficient of x squared, and in our case we said it is 1, then b is the coefficient of x, and then c is this 12 here. So if I want to factorize this question, the first thing I want to do is to look for two numbers. I can call them m and n, such that when I take m, I add n, I get b. In our case, b is 7. So addition of m plus n should give me b. Then the same two numbers, when I multiply them, they should give me c. So when I take m multiplied by n, it should give me c, and in our case, c is 12. So in this case, which two numbers, when we add them, they give us 7, and then when we multiply them, they give us 12. Those two numbers are 4 and 3, because when I take 4, I add 3, I get 7, and then when I take 4, I multiply by 3, I get 12. So from there, since now I have the two numbers as 4 and 3, I can factorize these two numbers inside the equation. So it becomes x squared plus 4x plus 3x. Look, this one, I took the 7 instead of writing it as 7 and just simplified it as 4x plus 3x, which would otherwise be 7x. So I replaced it with these two numbers, then plus our c, which was 12, is equals to 0. Then from there, I can divide this equation into two parts and factor out the common or the HCF in both sides. So here we have x squared and 4x. So x is common here. Then I can put in brackets x, because x multiplied by x, it will be x squared, then plus 4, because x multiplied by 4, it will be 4x. Then I come here and put that addition sign, and I factor out the value which is common here. And in this case, it will be 3, because if I take 3, I multiply by x, it will be 3x, then plus 4, which 3 by 4 will be 12, then is equals to 0. But then you see this x plus 4 and this x plus 4 are just the same. So I'll just pick one. Then the ones outside the brackets, I'll add them. So it will be x plus 3, like that. This x plus this 3. Then I pick one of these, which is x plus 4, is equals to 0. And then it means then x plus 3 is equals to 0. And also x plus 4 is equals to 0. So from there, I can say x is equals, I take 3 on the other side, and 0 minus 3, it will be negative 3. And then x plus 4, I can take 4 on the other side, and 0 minus 4, it will be negative 4. And that becomes the solution for this question. X is negative 3 and x is negative 4. Can you try this question 4 and see if you understand? It's the same concept, on that we changed the signs. So still, this is a monic, a non-monic, quadratic, because the coefficient of x squared is not 1. So in this case, it is 2. And we go the same process where we say you look for two numbers. We can call them m and n, such that m plus n will give us 7. It will give us b, which is 7 in our case. Then m multiplied by n. Now, in this case, it will give us a multiplied by c. And this a multiplied by c is the coefficient of x squared, which is 2, multiplied by this c, which is 3. So it will be 2 by 3, which is 6. So we look for those two numbers, and I think the two numbers are 6 and 1, because 6 plus 1, it will be 7, and then 6 multiplied by 1, it will be 6. So now that we have the two numbers, they are 6 and 1, we can factorize them in our equation here, where now we can start with 2x squared, the number 1, then we factorize this term for 7x. Instead of writing 7x, I can just write it as 6x plus x, because 6x plus x is 7x, then plus our c, which is 3, is equals to 0. Then I can divide the equation into two parts like this. So I factorize the common term in the first part. We have 2x squared plus 6x. So I know 2 can divide 6 4. So I can put 2 outside. Then this x squared and x, 1x is common, such that when I put x here, now it will be 2x multiplied by x, it will be 2x squared, then plus, here I can put 3, such that 2x multiplied by 3, it will be 6x, then this plus, here x plus 3, there is no common term, so I can just say the common term outside the brackets is 1 into x plus 3, because 1 multiplied by x will be x, then 1 multiplied by 3, it will be 3, and it will just make this part remain the same, is equals to 0. So, since this x plus 3 and this x plus 3 are the same, I can just pick one, then the ones outside the brackets, I add them. So it becomes 2x plus this 1 into x plus 3, picked one of these, is equals to 0, like that. So it means 2x plus 1 is equals to 0, or x plus 3 is also equals to 0. So in this case, 2x plus 1, I can say 2x is equals to, I take 1 on the other side, which will be negative 1. And then to get x, I can divide both sides by 2. And now I get x is equals to negative 1 over 2. And here, x plus 3 is 0. So when I take 3 on the other side, it will be x equals to negative 3. So the solutions become x equals to negative half and x equals to negative 3. So can you try this question 6 and you see if you understand the flow of the logic? If you don't, you can leave a comment, ask me any question, I try to solve. And bye for now. Let us meet in the next slide.